Okay, let's get started with long-term liabilities and the impact of interest that is charged on liabilities. Anytime you borrow money, there's a cost attached to it, and the cost attached to this borrowing is interest payments. We'll be looking at bonds, which is a long-term liability. What's unique about bonds payable is the principal amount that's borrowed today will be repaid at the end of the life of the bond. And during the life of the bond, you will be paying interest. This is different from installment notes and something that you're familiar with buying a car or buying a home. In those cases, when you make payments, you're paying towards principal and interest. In this case, with bonds, we're looking at only interest payments over the life of the bonds, and the entire amount that you borrowed, all of it is outstanding the entire life of the bond. It's paid all the way at the end. So in order to calculate the bond issue price or the bond selling price, we need to find the present value of two sets of numbers. The first one is the principal and the second is the interest payments. The interest, unless mentioned otherwise, is paid annually. If it is paid semi-annually, quarterly, or monthly, we'll need to make some adjustments. For annual payments, there are no adjustments that we make. So let's take a look at some exercises over here. The first is we are borrowing $1 million. That's the first piece of information. In the first case, we are saying we are borrowing it, and at the end of 10 years, we will return the money. Maturity means end of life. At the end of 10 years, it matures, that amount is due. Interest is paid annually, which means just once a year. The bond interest rate or the stated interest rate is 10%, which means that's the number on which I'm going, on this $1 million, this is the interest I'm going to pay, 10%. On the day of issue, the market rate is 12%. It's more than what I'm offering. Therefore, what we know is I will have to sell my bonds at a discount. Let's see if this works out or not. Again, if it's annual interest, no adjustments, so these numbers just stay the same. I'll explain the others as we come to those other situations. So I'm borrowing $1 million, that's the principal amount. Always, the interest that is paid is on that principal amount. So on that $1 million, I will pay whatever is the adjusted stated interest rate. Now, in this case, I told you it's the same as the stated interest rate, 10%. So 10% on $1 million is $100,000. Now, the next thing I need to do is calculate the present value of these two numbers. The principal sum that I borrowed today, I will repay it. It will be a cash outflow for me only once at the end of 10 years. So at the end of 10 years, I'll have a cash outflow for $1 million. What's the present value of that single sum? I look up table 2 for the present value factor. For the interest payments, I will be making a $100,000 payment each year for 10 years. So it's a series of cash flows. It's an ordinary annuity. So I look up table T4, table 4. So when I look up this table, the factors I'm going to look up for n equals 10, we already decided on that. The interest rate is the market interest rate, not the bond interest rate. I discount it at the market interest rate. So be careful which number you're going to pull out over there. So I look up the tables, table 2 and table 4, and find the factors. Again, n equals 10, I equals 12. And then I multiply those numbers across. That's called the extension. Once I've done that, add up the two numbers. It has to be less than $1 million, which it is. Again, remember, I offer 10%. The market is offering 12% at the time of issue. So I have to sell my bonds at a discount, which basically means I agree to accept $886,992. I will pay interest on $1 million and I will return $1 million. So this is the first example. Now let's look at what's different in the second example. Again, the term is still 10 years. The stated interest rate is still 10. The market rate is still 12. What is different now is I say I will pay interest 2 times a year. So if I'm paying interest 2 times a year for 10 years, I'm making a total of 20 payments. So the adjustment for n, the number of payments, is now going to be multiplied by 2. 10 multiplied by 2 is 20. I'm not going to pay 10% 20 times. I will pay 5% each time. So 2 times a year, 5% adds up to 10. And the market rate also I adjusted by dividing by 2 to come up with 6%. Again, I'm borrowing $1 million. On the $1 million, I will pay 5% interest, which is exactly half of what I had before. That's 50,000. And I'm going to pay that interest 20 times. It adds up to the same dollar amount in terms of interest payments, but it's just how it's spread out. Now, when I look up the time value of money table, I'm looking at N equals 20 because that's the adjusted number. I equals 6% because that's the adjusted number. Look up these factors. Again, do the extension and then add them up. Again, you will come up with a number that is smaller than the $1 million you're borrowing. And in fact, it's slightly lesser than even the first case, the money that you're getting. That's because of the present value calculations. Now let's look at a situation where 10 years, semi-annual payment, stated interest rate is 10%, market rate is 10%. I really don't need to go through any calculations. What I do know is it should issue at face value because stated and market rate are exactly the same. But let's go through the motions of doing all the calculations. I'll pay interest 2 times a year, so a total of 20. Semi-annual, since it's semi-annual, the interest rate, stated rate is adjusted down to 5. And the market is also adjusted down to 5 from the 10 that we have over here. Again, when I look up the table and look up the factors, now I'm looking at present value for 20 periods, I equals 5. Now, whether it's this 5 or this 5 doesn't matter, it's 5%. Go through all the calculations as we need to do, and what you will see is you will get exactly $1 million. We're off by a dollar, that's a rounding error, that's fine. So what we're looking at over here is my bonds will issue at $1 million because the market rate and the bond rate are exactly the same. Doesn't matter whether the interest rates are semi-annual, annual, it doesn't matter. It's these two numbers, the difference between these two numbers that makes a difference. Now, having said that, let's look at this. The bonds are going to mature, same $1 million. The bonds will mature in 20 years. Interest is payable semi-annually. I am offering 12%. I'm the borrower. I'm offering 12%. The market for similar risk is offering only 10%. So will I be able to issue my bonds at a discount or a premium? It's the opposite of the situation over here. Let's take a look at what we had over there versus over here. In the second case, we had said we were offering 10 and the market was offering 12, which is why we issued our bonds at a discount, okay? Now we are saying we are offering 12 and the market is offering 10, so we should issue it at a premium. Let's see whether that works or not. So I'm going to hide these columns so I can show you the other side of my Excel spreadsheet. So I'm looking at part 4. Again, principal that's being borrowed is $1 million. $1 million will have to be returned. Let's do the adjustments over here. I have N equals 40. Some annual payments, so multiply 20 by 2 to come up with 40. Stated interest rate is 12%. So adjust it down to 6. 6% of $100,000, sorry, of $1 million is 60,000. And when I look up the time value of money table, now I'm looking up N equals 40 and I equals 5%. Look up the factors in table 2 and table 4. We go through the motions of calculating the extensions, and what we come up with is in fact a number larger than $1 million. So the excess amount that I have is a premium that I'm going to issue it at. Bonds will issue at a premium because I am offering an interest rate that is larger than the market rate at the time of issue. The last one, again, market and bond rate are the same, like we had 10 and 10. Here you have 12 and 12. Again, you don't need to do the calculations, but when I do the calculations, I go through the motions. Here's what I'm going to come up with, a number very, very close to the $1 million. I'm off by $2. Again, that's a rounding error. That's fine. So you come up with $1 million. If your bond interest rate and market interest rate are the same at the time of issue, you will issue it at face value. If the bond rate is lower than market, you'll issue at a discount. If the bond rate is higher than market, you will issue it at a premium. So once again, to recap what we need to do, check to see if interest is paid annually, semi-annually, quarterly. If it's annual, no adjustments are needed. If it's any other way, any other number of payments, you need to make that adjustment first. For N, you will do the multiplication. For the interest, you will do division, you will divide. Once you have that, it's the market interest rate that you need the time value of money table, those calculations. The stated interest rate is for the interest payments. So this is always step one to calculate bond issue price before you can do anything else as far as bonds are concerned. Unless, of course, you're given the bond issue price in the exercise.